Okay, so we'll just finish out the pending portion. A very small pending portion is left. We have to see uniform distribution, exponential distribution, and a normal distribution, right? So uniform distribution is a simple probability density function is there, right? So we have some range in which the function output is constant. Apart from this range, the function output means the value will be zero. Right. So here we can work out. Here we can work out for this. Right. So if I try to draw this, right. So let's say this is my x-axis, right, and let's say this is that constant value k. That this is that constant value k, right? That is constant. So this is x is equal to a, right? So let's say this is x is equal to b, right? So this is y is equal to k, or f of x is equal to k is there. Now, can you find this constant value? Yes, we can find this constant value because we know that area under this probability density function from minus infinity to plus infinity will be equal to 1. Right? So minus infinity to plus infinity f of x dx, that is equal to 1. I know that from minus infinity, good evening, from minus infinity to a, there will be no output, right? Because output is coming only in this range. Output is coming only in this range. So here from minus infinity to a, there will be no output. From a to b, we have output, and b to plus infinity, we don't have any output. So finally, this we can write as, right, a to b, right, f of x is k, and this is dx, that is equal to 1. And k is constant, right? K is constant. Right, k is constant. So you have to just integrate this. So this is x, limit a to b, that is equal to 1. And this will come out as k, right, that is b minus a, that is equal to 1, which implies k value is nothing but 1 upon b minus a. Right, k value is nothing but 1 upon b minus a. So this k value I came to know. So that is 1 upon b minus a. Right, so for this uniform distribution, this k value you can easily calculate. So it's a simple function. So for any probability density function, this will be valid, right? For minus infinity to plus infinity, the area under the curve will be equal to 1, right? So that gives me the value of the probability only. Right? So if we talk about the mean, right, variance of this, so mean always all expectation of this, right? Expectation of this function, right? Or this distribution. Right, that is equal to this. General formula for continuous variable is, right, so minus infinity to plus infinity x f of x dx. So that is general formula for any continuous variable. For any continuous variable, mean or expectation is like this, right? So you have to just put f of x over here, right, and then multiply with the x, right? Then integrate with respect to x, keep the limit from a to b. So this we have from a to b, only limit will come, because other than this x, the output is 0. And this is x into k, and k we know that it is 1 upon b minus a, 1 upon b minus a dx. So 1 upon b minus a, you can take common and all, right? So finally I'm just putting the answer, right? It's come a plus b divided by 2. So it's simple. You have to just remember this value only. It's a mean, right? Arithmetic mean of the limit. So x square by 2 will come. You just put the limit b square minus a square by 2. Right? Then will become b plus a, b minus a, b minus a, b minus a will cancel. A plus b by 2 will be left over. Now similarly, we have a variance also. Sigma square. General expression we know expectation of x square, right, minus expectation of x whole square, right, and expectation of x square, expectation of x like this, right, minus infinity to plus infinity. This is x square into f of x, right, dx minus expectation of x whole square. So the general formula. Now what is f of x? Just put it over here. F of x is a, and a is 1 upon b minus a. So a to b, right, x is 1 upon b minus a, b minus a into dx minus, this is just now we have calculated, this will be whole square, right. Now you have to just solve for multiplication. This will be constant x, right. So finally your variance will come out to be b minus a divided by 12, right? And standard deviation b minus a upon root 12. Then we have the other function, other distribution, exponential distribution. So these are continuous variable function. Right. Then we have exponential distribution. So in exponential distribution, the probability density function is given as, so it's exponential function, definitely exponential function will be there by f of x, that is equal to, right, some constant lambda e raised to power minus lambda x for x greater than equal to 0, and it is 0 for x less than 0. So this is the exponential function. The output exists for all the positive value of x, negative value of x, there is no output. So as x will increase, this output will decrease, right, because the exponential decay is there. E raised to power minus lambda x is there. So if I try to plot this is y axis, this is x axis, this is 0. So for x greater than or equal to 0, we have this exponential function like this, it will keep on going, right. So we have this portion of the curve existing. Here we don't have any curve because x less than 0, no output, right. So this is what it is defined, exponential function, right. So this is your f of x existing here. Now we know that whatever probability density function is there in the any continuous variable, right, we always have this general thing, minus infinity to plus infinity, f of x dx is equal to 1. That will be always valid. Means area under the curve, right, from minus infinity to plus infinity will be equal to 1. Right? Now if you are asked to calculate mean or expectation of this, mean or expectation, right, that is, the general value is minus infinity to plus infinity x f of x dx, right. So you have to just put this f of x only, right, but you just have to remember the final result, right. Final result you have to remember, that will be more useful, 1 upon this lambda. It's very easy results are there, right. You have to just put f of x e raised lambda e to power minus lambda x, right, and put the limit from 0 to infinity, because minus infinity to 0 you don't have any output. So from 0 to infinity only you have output. and finally you get 1 upon lambda. Simply variance variance, that's sigma square. Now we know that variance is the general formula is minus infinity plus infinity x, right? F of x dx minus expectation. Again, you have to put the same function, you have to integrate and all, right? But just remember the final result. It's very simple to remember also. It is 1 upon, right, lambda square. And once you know this, standard deviation is root over variance. So it is 1 upon lambda. Standard deviation sigma. The standard deviation is nothing but sigma only. That is sigma 1 upon lambda. So 1 upon lambda square, then 1 upon lambda. And the last distribution is, that is slightly important, normal distribution or Gaussian distribution. So here probability density function is given by, right, is given by, right, f of x, that is equal to 1 upon root over 2 pi, right, this variance, right, sigma square, or you can take out also, it will be sigma into root 2 pi, right, then multiply with e raised to power minus half, right, x minus mu by sigma, this is whole square, right? So this is your f of x, probability distribution function, 1 upon root over 2 pi sigma square multiply with e raised to power minus half into x minus mu upon sigma, that is standard derivation. So what is mu and all? This mu is nothing but mean or expectation. This mu is nothing but mean or expectation. And then we have sigma square, that is nothing but variance. And sigma we have, that is standard deviation. Right? Now, if you try to plot this, you will get a very nice bell-shaped curve, symmetrical bell-shaped curve about mean, right? Like this. So like this bell-shaped curve you get. And this bell-shaped curve, if you see, it is symmetrical about this vertical line, right? Y-axis. So this line has been kept about mean value. X is equal to mu, right? About the expectation or mean value, this total curve has been split into two halves, right? About this mean value, right? When x, this is all x-axis, this is x-axis, so x is running here. So when x is equal to mean or expectation, about this vertical line, this whole curve is equally divided into two halves. How much portion is here? The same portion is over here. This is very interesting, very useful information for the problem solving also, right? About the mean value, about the expectation value, this whole bell-shaped curve is divided into equal half, right? And remember, this is a probability density function. So don't forget minus infinity to plus infinity, area under this curve will be equal to 1 only, right? Total area, if you take the total area under this curve, that total area will be 1, and that area is nothing but probability only. Now it means that if this is 1, this total, you take 100%, 50% area is this, 50% area is this, right? So 50% area is divided, right? Because if total area is under 1 and then equally divided about this mean value, you will get a total value divided into two halves, right? So 50% left, 50% right area is there, right? So remember, this is symmetrical. This is symmetrical about mean line. Symmetrical about mean line. Totally symmetrical about mean line. Right. And that mathematical function which we have kept over here, this is the plot of this. This is the mathematical function which you have seen over here. This is a graphical plot of this. Right. So basically, this is only your f of x total. So if area under this complete curve gives me the probability, and about mean line, you see equal half is there. So this is also half, this is also half. So I can write here, right, first probability of x less than mu, less than this, is also equal to the probability when x greater than mu, and that will be equal to 0.5 only, or 50% only. Hey, this is one unique information, fixed information. About the mean line, this is a fixed information. You go this much area, you take this much area, 50%, 50%. So probability will be 0.5, 0.5, because total 0.5, 0.5 will add and make it equal to 1. Right? And if you want to find the probability anywhere between two limits, right? For example, probability between x less than equal to b and greater than equal to a. So you know the basic understanding from a to b, f of x dx you will do, right? And then you will calculate this probability, right? But you know what f of x will be put? F of x will be this function. This whole function you have to put, and you have to perform the integration and put the limit. This becomes very tedious, right? You have to perform the integration of this exponential function. So it will become very tedious and very lengthy, right? So we don't follow this, although you can calculate probability between any two x values, right? Between any two x values from a to b, you can calculate probability by just taking area under the curve from that two limits, right? So that is not so easy, right? I won't say that it is not able to calculate. It's not easy, but because it's not able to easy, we have another rule, another funda. So we use z-score. There's a new concept here. We use z-score. It's not so easy, so we use something called as z-score. What is this z-score? See, z-score is defined as x minus mu upon the standard deviation. Right? So this is what is used. So z-score table is given. Datas are given. Just like you have a steam table, right? We have a table of z-score, right? For different values of z, for different values of this, we have a z-score already set. Now, if question comes, they will always give you the value of z, right? So how to use this z-score? So see here. So z-score understanding is important. Z-score is equal to x minus mu upon sigma. We know what is this x. X can take any value, right? X can take any value here. X can take any value over here. Mu is what? Mu is basically this expectation, and sigma is standard deviation. Now, when x is equal to mu, or when x is equal to expectation, this numerator will be 0. Z-score will be 0. So I came to know that wherever I am having this mean value, expectation value, here z score is equal to 1. Sorry, 0 over here. Because x is equal to mu. Here z score is equal to 0. So here z is equal to 0 value. It will take 0 value. Because that's how it is defined. You keep x is equal to mu. Means your exactly x value coincides with the expectation value. So z score will be 0 over here. So when x correspond to expectation value, your z score become 0. Now, if you take z score is equal to 1, then what is the x value? If you put z score is equal to 1, so x value will be equal to sigma plus mu, right? Sigma plus mu. So here I'm getting one z value. Right? So here is z is equal to 1. When z is equal to 1, for me, x value is what? Right? X value is equal to sigma plus mu. Sigma plus mu. So z is equal to 1 correspond to this value, sigma plus mu. When z is equal to 2, if you see this again, when z is equal to 2, so x is what? 2 sigma plus mu. Right? So when x is equal to, right, 2 sigma plus mu, so we have z value equal to 2. And when we have z value 3, so x value will be what? Right. X value will take 3 sigma plus mu, or z is equal to 3. Z is equal to 3. So we have taking some discrete value of z. One value of have taken 0, one value 1, one value 2, one value 3. What is this corresponding on the x-axis? Also we come to know, because z is equal to x minus mu upon sigma. If z is equal to 1, right, then you will have sigma, x is equal to sigma plus mu. If z is equal to 2, then 2 sigma plus mu. Then z is equal to 3, so 3 sigma plus mu. Right. Similarly, you will have z is equal to minus 1, minus 2, and minus 3 also like that. Right. Okay. Similarly, we'll have this also. Right. Similarly, we'll have x is equal to this. You can write mu minus sigma this time. Mu minus sigma, right? This is x is equal to, right, mu minus 2 sigma, like this. And this is z is equal to minus 1, this z is equal to minus 2. Similarly, z is equal to minus 3. We'll have, right, put z is equal to minus 1, minus 2, minus 3. Like that, you can get x value correspondingly. Right? So in this way, we have this information. Now, after getting this discrete value of z, we know that this curve, total curve, is distributed equally on both the sides by this vertical line. It means how much distance you go ahead, right? Same distance if you go behind, right? You're going to get equal area, right? Equal area, right? How much distance you are going ahead. For example, I am going from z is equal to z is equal to 1. I will take some area. Right? Right? This much area I will take under the curve. If I go from z is equal to 0 to z is equal to 1, and if I go equal distance backward, I will get this much area, and this area, and that area is almost means exactly A. This area is also A, this area is also A. Both area will be same, right? Both area will be same. This is also A, this is also A, because it is symmetrical about mean line. So how much you go ahead of this, that much you go behind this, you're going to have a same area under this curve. This information is very crucial for problem solving also, right? And now this area you should remember also. It means when you move from z is equal to from minus 1 to plus 1, this total area will be 2 times of A, right? So just remember these z values, probability. So probability of z, right, less than equal to 1 and greater than equal to minus 1. This probability is nothing but 0.68, right? Just you have to remember these values, only 3 values. probability from z going to means less than equal to 2 but greater than equal to minus 2, this probability will come to be 0.955. So we're moving closer to 1. And if you take this probability from z less than equal to 3 but greater than equal to minus 3, this total probability will be equal to 0.997. Right? So this probability you have to remember for z is equal to minus 1 to 1, minus 2 to plus 2, and minus 3 to plus 3. Right? Means what? Right? From minus 1 to plus 1, minus 1 to plus 1, this total area will give me the probability, right? Total area will give me the probability, and that is coming out to be 0.68. This total is coming out to be 0.68. 0.68 total area, right? Because total area under this is giving me the probability from z is equal to minus 1 to z is equal to plus 1. The value is coming to be 0.68. So if you perform that integration, keeping that big function over here, right, then you will get equal to 0.68, right? Now, if this much is total 0.68, then how much is this portion? How much is this portion? It is 0.68 divided by 2. This much is also 0.68 divided by 2, right? 0.34, because equal area is shared about this axis, right? Similarly, if you take this, right, suppose I take z is equal to minus 2 to z is equal to plus 2. So how much area I am getting? That will be the probability. And we have written already, right? We have written already from minus 2 to plus 2. From minus 2 to plus 2, the probability is 0.955, right? So this probability is nothing but area under this curve only, right? So this value will be what? This much value has been given to me, right? Right, 0.955, right? 0.955. This total area, right? Now, if you go from z is equal to minus 3 to plus 3, z is equal to minus 3 to plus 3 here, right? Then we have 0.997, right? This total area which you will get under the curve is, right, 0.997, right? So green color is up to here. So this is the meaning of Z score, right? So from minus 1 to plus 1, the total area under the curve is 0.68. So half or half you can divide equally. From minus 2 to plus 2, the total area is coming to be 0.955, right? And from z is equal to minus 3 to plus 3, total area under this curve is coming to be more. You can see 0.997. So we are going closer and closer to 1, right? Let's take a problem on this. So let's take a problem on this. Such type of problems are still waiting to come, right? Because it's very highly relevant to the normal distribution, right? So X is a normal random variable with mean value is coming to be 50, right? And it is be given the probability when this random variable is greater than equal to 55 is equal to alpha. Now what they're asking, find probability when random variable is less than right? 55, but greater than 45. Right? We have to find this. See how to make use of this information. Just quickly draw the bell-shaped curve. Just quickly draw the bell-shaped curve. Okay. What they have given? Mean value is 50. So mean value will be here. Right? This is mean value. Okay. Okay, no problem. Minutes are there. You just finish it out. So x is equal to mu. That is equal to given as 50. Right? Mean value has been given 50. What is given to me that x greater than equal to 55, the probability is alpha, and probability is nothing but area under this curve. Where is x is equal to 55? Over here. Right? X is equal to 55 will be here. If you go plus 5 ahead, you get 55. Right? And this is what? This is what? Hidden. Probability greater than this. It means they are giving you this area. This area has been given. This area has been given to you as alpha. This area has been given to alpha. Right? And they're asking the probability within this range or area under this range. So see, 55 is here. Where is 45? We go 5 below, 5 behind this. Right? So it will be x. Right? X is equal to 45 will be here. Right? Right? This. Right? Plus 5 you are going ahead. 55 minus 5 you go, you get 45. Now you see, this is the curve which is equally distributed. So how much you are going this side, that much you are going this side. So equal coverage of this area is there. This area will be equally covered. So this area will be also equally covered. This also it will be area equally covered. So this will be also taking the value of alpha. Right? This also will take the value of alpha because of its symmetrical curve. Right? You are getting 5 unit ahead, 55. You're going 5 unit behind, 45. So this area is equal. This area is equal. Right? So it means this much green portion ahead of 55 is as good as this much area behind 45. So this will also have the alpha value. Now what do you have to find? You have to find this much probability in this range, right? Or area just find in this range, right? Area just find in this range, right? So area, very easy to find. We know this type of this much area, right? So see here, we know that total area under this curve will be 1. Total area under this curve will be 1. So a plus 2 times of alpha, a plus 2 times of alpha is equal to 1, right? A plus alpha is equal to 1. That will cover the complete area under the curve, right? And this I can calculate very easily from a, right? A is what? 1 minus 2 alpha. This will be the answer. A is equal to 1 minus 2 alpha. Right? So we have just used this concept is bringing this only, that minus infinity to plus infinity f of x dx is equal to 1. So area under this complete curve will be equal to 1, and total area will sum up with alpha, this a, and that is equal to 1. So a is equal to 1 minus 2 alpha, and a is what? A is the area from this 45 to 55, right? And this area is nothing but the probability only. The area under this curve will be probability only. So we have found the probability only from 45 to 55. Right? Okay. Just keep it. Okay. Hey, so these questions are very interesting, and these questions can come any moment of time because GATE has started to focus on this type of distribution in the recent years. GATE has started to focus on this Gaussian or normal distribution, right? So they can use this type of analysis also. They can bring out the area analysis. Just remember this bell-shaped curve, right? It's symmetrical about the mean value. how much portion of area is this side, that much portion on the left side. And area is nothing but here the probability only. So 0.5 probability is coming left side, 0.5 probability coming this side. That's why total will become +1 probability, right? So this is the key idea, right? Now from z is equal to 0, that is mean value mu, z is equal to 1, you are going this much distance plus mu, right? So z is equal to -1, how much distance you are going? Minus this you are going, right? Mu minus sigma you are going. Now you see how much you're going ahead from z is equal to 0 to z is equal to 1. That much you are going from z is equal to 0 to z is equal to -1. So this area, this two area will be same. And we just came to know the probability, but from z is equal to -1 to +1 is 0.68. And that is nothing but the total area under here. So if you know the individual area, you can half it. You can halve the total area. So this type of analysis will be used. Right? We'll take one more question. Okay. So let x be a random variable with mean 30 and standard deviation 5. Standard deviation 5. Right? What is the probability what is the probability right of this to get, right, when random variable is greater than equal to 26 but less than equal to 34, right? Given that, what is given? Given that areas from z is equal to 0 to z is equal to 0.8, right? 0.8 is 0.2881. This is given. So z value you will be given, right? Just you have to remember z value for 1, 2 and 3. So let x be a random variable with mean 30 and standard deviation 5. What is the probability of getting random variable from 26 to 34? Given that area from z is equal to 0.8, So see, about mean, the mean is 30. So this is 34, this is 26. So you can see about mean we are going 4 unit ahead and 4 unit behind. So some area utility will come over here. Some area concept will come over here. So first thing to deal with this, just plot the curve. So again, for this complete curve, from -infinity to +infinity, f of x dx is equal to 1. Means total area under this probability function is 1. Right? Because probability maximum value will be 1, minimum value will be 1. It is given that mean value is 30. And what is asked the probability between the random variable from 26 to from x is equal to 26 to x is equal to 34. X is equal to 34. This has been asked. Right? If you collect the area, like this, right? So this area will be equal. This area will be equal because this is symmetrical. How much you're going ahead, that much you're behind. So you will cover equal area because it's totally symmetrical curve from -infinity to +infinity. This is totally symmetrical curve about this vertical axis. Right? Now, how to use a z-score? They have given from z is equal to 0 to z is equal to 0.8, right? 0.2881. Area under this z limits has been given to me. So see, first let us try to calculate z-score. We know that for z-score, for the mean value will be always 0, right? Because z is defined as x minus mu upon sigma, right? Z is defined as x minus mu upon sigma. So when x is also equal to mu, that is basically this expectation only, right? So you will have z is equal to 0. So let us see what is the Z score for 34 and 26. Let us see. So Z is here. X is what? 34. Right. Mu is what? 30. Standard deviation has been given to us. That is 5. Right. So this is 4 upon 5. That is equal to 0.8. 0.8 will come. Z score for X is equal to 34 is 0.8. 0.8 will come. Right. Now calculate the Z score for 26. So Z is equal to X minus mu upon sigma. This is basically, I have to find, this is 26 minus 30 divided by 5. So it is basically minus 4 by 5. So it is equal to minus 0.8. And it has to be, because how much you are going ahead above 30, that much you are going behind 30. So Z will take the same sort of magnitude. Right? This is 0.8. Z is equal to 0.8 minus 0.8. And if you see the question, they have given the area. They have given the area from 0 to 0.8. Right? From Z is equal to 0, from Z is equal to 0 to Z is equal to 0.8, this area has been given 0.2881. Right? This area has been given. Right? From this Z is equal to 0, from Z is equal to 0 to Z is equal to 0.8. This complete area has been given 0.2881. This total area has been given. I have to find what? Probability from 26 to 34 is as good as finding probability of Z from minus 0.8 to plus 0.8 is as good as finding that only. Right? So see here. So we have to find probability from minus 26, oh sorry, this 26 34. That is where to find. It means I want to find Z score in terms of Z score. If I find minus 0.8 to plus 0.8, this only I have to find. Right? These X values I can replace by the Z score. So minus 8 to plus minus 0.8 to plus 0.8. I have to find the complete probability here. I know this is equal. These are equal. These are equal areas. Right? Already answer, just bringing in the format. This also should be 0.2881. So from here to here, I have to just multiply these two areas. And area is equivalent to probability only. So this, to find this, I can find this also. 2 times the probability. Right? Right? So I can find this also, probability. 2 times probability of Z 0.8 to 0. I can find this also. 0 to 0.8, what is the value given? Multiply with 2. So get a total. Right? So this is 2 and this has been given 0.2881. Right? Right? So that will be near about 0.5762. 0.5762. Right? So whole plays with the understanding that equal area is shared. Right? How much you by going equal distance ahead of mean value. Right? You go equal distance ahead and behind the mean value, you will share equal area. If you know any information of one side of the area, it means you know this side area information also. It means you know total information of the area. And information of the area is as good as knowing the probability from this to this. Right? So that is why intentionally they gave me Z score area, means area under from the Z score 0 to 0.8, because it was used in this problem like this. Okay, so this we have done here. Right? No. So what we'll do now, right? We will try to revise the things. We'll try to revise the things, right? Let's say through test, right? Plus assignment, right? Right. We'll do some test and assignment. We'll do the test on Telegram, right? We'll do organize a test on Telegram. We'll see how, right? I will fix a time, right? See, we'll just work out with the test because practice part is needed now. We'll do as much as practice. We'll take the questions from other branches also, and we'll try to solve it, right? I'll give you the solution also for that, right? And some assignment also I will give you. So in that also you have the more of the practice, right? So test will be conducted in Telegram only. See how it will be conducted. I will give you the slot, right? I will give you slot, that is time slot, right? Time slot I will give you. I will just put a poll also that which time slot you are comfortable, right, to give the test. Maybe from 10:30, right, to 11 p.m. right, night, right, from 10:30 to 11 p.m. Just 10 questions solve in 30 minutes. I will send one question at a time. I will give you 3 minutes, 2 minutes, right? And then you have to solve. Once you have done the solving, you have to just tell by putting a like on the question that you have done this problem. Then I will share the next question. Once you have attempted that question fully, put the like on the question, so I will understand you have attempted the question, and I will also understand your speed and all, right? How quickly you are putting the like on the question. I will understand the speed at which you are answering, right? So in this way I will give you some 10 question as per the day, right? Then we'll do another day, right? One topic I will share. I will just share the schedule also. I will just share the schedule of the test, right? Like this day this test, this day mattress, right? Or let's say I'll divide the topic wise, more topic, like this day up to the rank I will ask in the matrix, so more questions I can throw. And then I will ask from your eigenvalues and the solution of the equations. That's again I can bifurcate. So I can bifurcate the one chapter into two parts for more of the question practice, right? So in this also we'll go. So we'll conduct a test in the Telegram. We can easily conduct these things, right? So you will have some with time limit. You can also solve some questions, although you are giving test series, I'm expecting, but this also will give you some urgency, right? Some triggerness to solve the questions of the variety which is more gate oriented, right? So might be in test series you can find some questions which are very much like I say challenging or more difficult type, right? But we have to see that we are solving the gate oriented problems or not, right? Because they are not going to challenge or going to hurt you like that, right? They're going to give you questions, a decent questions, so they can understand your basic concepts. So first we'll solve the question which is very much oriented from the gate professors, right? Or which is likely to become in gate exam. So we'll do that part first, right? Then you can solve your test series as many questions as you can. So gate oriented problems only I will be sharing in this, right? Timing I will just ask you. I've just given you this. It's not this timing. I will ask to you in which timing maximum people are comfortable to come live and give the test amongst their peers, right? So this we will do, right? Anything more? Anything more from you, Satya? Okay. Fine. Restate. Okay. So what we are saying that we are working for the practice part. Practice part will be from the test and assignment, right? In the Telegram only we'll put the test, right? I'll put a poll for to check what time slot maximum peoples are comfortable to come live and give the test on the Telegram, right? What I will be doing, I will be sharing a question. One question I will share. Can say a photo of the question will be there. Once you try that question, you have to just like that question. Once you have attempted, if you have not able to attempt, then no need to like, right? So I can understand how many people are able to clear that question and what speed they are solving that question, because time and everything will be counted from there, right? So once you have done this question, after 2-3 minutes I will send one more question, right? I'll be also on the live. Then you will be giving 10 questions at least, minimum 10 questions at least in 30 minutes test, and then I will share you the solution of that. In this way you will be able to learn, and you will be also getting confidence with the practice part, and you will be also doing this practice amongst your peers only, right? As many people will come participate, that will be very good, right? So in this way you will be having the practice part. Schedule of the test I will share, right? Maybe I can give one day matrix test, right? One day matrix test, or I can divide matrix into two parts, from the basic to the rank calculation, and next day from the solution of the equation to the complete eigenvalues. So you get more of the questions for the practice, and solution also I will share, right? So that also will make some understanding, right? So in this way we'll be able to cover the revision part also. Getting this? You can just post me. You can just post me, and I will just give you the solution of that, and a photo of that detailed solution I will also give you. Right? You just keep on posting the questions, right, to me. You just send me the photo of the question. I will respond back. Right? Right. So anyone who's having the questions, they're finding right. Yeah, that will be taken. This will be has already discussed. This will be taken by the this answer, right, in PDs lectures, that Laplace has been covered there, because that is a part of a technical subjects, right? So Laplace and these things will be taken care by the sir in that course, right? PDC course, right? Anything? Chapter wise test, please inform 2 days before the test. I will inform you. I will give you the full schedule. I'll post it, right? And just I want to know what time maximum people will be available to come on that live test, right? Because when urgency is there, when there's a time limit, then you think faster, you try faster, and then you take the confidence back and learning back, right? Where we should perform the calculus questions. Don't worry about the calculus questions. Whatever questions I will be forwarding you, you solve that questions, right? That questions will take care of the maximum of the concept, right? Which is from other branch also, and very much gate oriented. So those all questions you just solve. Don't refer to any books and all. There's no time ahead left to solve the question from the books. You see, the gate level problems are very much understood. There's a pattern in which they asked, right? So the calculus is very vast topic, right? If you take the book, you'll be totally confused, and a lot of things you will see. But calculus, as point of our gate chemical, we have to be restricted towards the previous question trend and the syllabus, right? So the questions which are coming, we have to practice like multiple integral, right? We have to practice that's vector calculus, that is very important, right? So we have to practice on these parts. I will sharing the questions, you just try to solve this, and also I will share the solution and all. So learning will be there continuous, right? So previous year question just solved. There are many questions has been asked from the other branches also. So if you go this much questions only, you will be able to get confidence. Even you yourself be able to predict the next year questions also with that. And even in the test series also, you will see the questions of that gate level which has been asked in all over the papers, right? Major papers which has been asked. So don't first go for any books, just go for previous year questions. The best practice material for mathematics is previous year questions, right? The best practice for aptitude are also previous year questions from all the branches, because these are common subjects for maximum of the branches, right? And then test series PYQ, test series PYQ. That's it. Okay, okay. Just share with me. I'll just revert it back. Okay. Okay. So thank you everyone. We'll be going right now through Telegram. We'll be connected, right? So just we'll be practicing through that, right? Okay. Okay. Thank you everyone.